Okay, good morning. So today we will start a new topic, 10.1 properties of the wave. So the wave is defined as the propagation of the disturbance that carries the energy and momentum away from the source of disturbance. Okay, so mechanical wave is defined as the disturbance that travel through the particles of the medium to transfer energy. Okay, so if you refer to this diagram, okay, if the motion is up and down, the wave motion is up and down. Okay, so the up and down motions of the road is perpendicular or 90-degree to the directions of the motions of the wave. So if your wave in horizontal and your motions of the wave is up and down, okay, so one is up and down, this is the motions of the propagation, and the directions of the wave is always perpendicular to each other. Okay, next, the particle oscillate around their equilibrium position but do not travel. Okay, so for example, water wave, sound wave, wave of the string, wave in the spring, and also earthquake wave, seismic wave. Okay, so all the mechanical wave require, so this one you must remember. So what is the requirement? This one will come up from objective questions. So all the mechanical wave requires some source of disturbance, okay, a medium that can be disturbed, a mechanism to transfer the disturbance from one point to the next point along the medium. Okay, so these are the requirement for mechanical wave. Okay, so the first one, progressive wave. So progressive wave meaning that the wave that can move, boleh bergerak. Okay, so defined as the wave propagate continuously. Okay, from the source of disturbance, dia akan bergerak, So the progressive wave have a definite speed. We call it speed of propagation, or we call it wave speed. Okay, so the directions of wave speeds is always same directions of the wave propagation. Okay. Okay, so next kita tengok propagations. Actually, we have two types of propagation. Progressive wave. We have two types of progressive wave. The first one is transverse. Okay, where wave in which the directions of the vibration of the particle is perpendicular to the directions of the propagation. Okay, so if let's say we say transverse wave, meaning that your wave is going up and down. Okay, your wave is going up and down, and the directions of the waves is always perpendicular to each other. So this is transverse wave. Transverse wave meaning that it is perpendicular. Okay. So example for transverse progressive wave is water wave, wave on the string. Okay, for example, rod. Okay, the second one, progressive wave, is the longitudinal, where the wave in which the directions of the vibration of the particle is parallel. So this is longitudinal. Okay, so your wave is travel in left and right. So we're moving to the left and moving to the right. Okay, and the direction is always parallel with the directions of the wave propagation. Okay, so ini adalah parallel. When you say the directions of the particle, the vibration is parallel with the motions of the wave, meaning that this is longitudinal wave. So for example, sound wave and also wave in the spring. Okay, wave in the spring. So these are the two types of wave for progressive wave. Wave yang boleh bergerak. Okay, wave yang boleh bergerak. So kita ada dua jenis. Satu adalah transverse, satu adalah longitudinal. Okay, so next, define wavelength and also wave number. So wavelength symbol is lambda, wave number symbol is k. Okay, so here, example, this is our wave. where this is the amplitude. So yang paling maksimum sekali kita panggil dia crest ataupun peak. Okay, yang paling atas ataupun positive amplitude. Okay, if let's say negative amplitude yang di bawah ini, yang bawah ini kita panggil dia trough. Okay, so here we have a wave where one complete oscillation from crease to another crease. Ini kita panggil dia satu landa, one landa. Okay, one landa. If let's say this is the graph, X graph. Okay, if this is the period, this is the time, meaning that this one will be period. Okay, this is the period. So, untuk satu ayunan lengkap, so for one complete oscillation, okay, satu ayunan lengkap, kita panggil dia landa. Okay, we proceed to page 214. So these are some terms that we need to know before we answer the questions. So some important quantities used to describe a periodic sinusoidal, maksudnya a sine wave, are shown in the table. So the first one is y, displacement. Okay, displacement. Okay, so the distance moved by the particle from its equilibrium position at every point along the wave. Okay, so this is your y. It's a distance. Okay, it's a distance where the particles travel. Okay, amplitude. Actually, we already learned during chapter 9. Amplitude is the maximum displacement. Okay, so we write as y maximum equals to A. A is the amplitude. Okay, A is the amplitude. Okay, frequency is the number of complete cycle that pass a given point per second. Okay, so your frequency is 1 over period. And your period, masa untuk satu ayunan lengkap, is the time taken for the particle to complete one cycle of its oscillation. Okay, so our period will equal to 1 over F. Okay, and angular frequency, or sometimes they will say angular velocity. Okay, so actually we are referring to the same thing, yaitu omega. So it's the rate of change of a phase of the sinusoidal wavelength. So we can write omega equals to 2 pi over t or 2 pi f. Okay, 2 pi over t or 2 pi f. Okay, next, wavelength. Wavelength is the distance between two successive crease. Macam tadi. Okay, dan mesti daripada crease to crease. Okay, from crest to crest. So this is your wavelength. Okay, or the distance between two successive identical points on the wave. So not necessary must always from peak to peak. Sometimes we can take as long as one complete cycle. Okay, we can take from equilibrium position to equilibrium position. So this one also consider one wavelength, one lambda. Okay, so this is lambda. Okay, K is the wave number where the number of waves exist in 1 meter. So meaning that your K will equal to 2 pi over lambda. Okay, phase angle. Phase angle shows the directions between the vibrations of one particle to another. Okay, so for example, when phase angle equals to 0, meaning that they are in phase. Okay, if there's no changing, so we say it is in phase. If your delta phase angle is pi over 2, when we say pi over 2, meaning that it is anti-phase, or we say out of phase. So for example, okay, let's say there are two waves. Okay, so initially they start with the same graph, meaning that it's a sine graph. This one also sine graph. Okay, so when they meet together, this one is positive amplitude. The second wave also positive amplitude. So we say there is no phase angle here. both of them are in phase. Okay, both of them are in phase because when they meet, they are in positive amplitude. Okay, whereas if let's say the first wave we have positive amplitude and the second wave, okay, we have a negative amplitude. So we say both of them actually there is a difference of phase angle where the phase angle is anti-phase, phase angle pi over 2. Okay, maksudnya satu atas, satu di bawah lah. Okay, so mereka adalah anti-phase, anti-phase. Okay, 10.1b. Solve the problems related to the equations. So, secara general, equations that we can use, the general equations of the displacement, we write as y equals to a sine omega t plus minus kx. Okay, so this is a general equations that we use to solve the questions for progressive wave. Okay, where your a is the amplitude. Okay, omega is the angular frequency where we can use 2 pi over t or 2 pi f to find. Okay, k is the wave number where your k is equals to 2 pi over lambda. Okay, so this is all the equations given. Okay, so we also have another symbol plus minus here. If you're referring here, we have plus minus. Okay, so when we say plus kx, meaning that your wave is propagate to the left. Okay, when you write negative kx, your wave is propagate to the right. Okay, so ini adalah ke mana gelombang anda bergerak. Kalau ke sebelah kiri, maka kita punya equation perlu tulis plus kx. If you propagate, you pergi wavelength is propagate, bergerak ke sebelah kanan, you perlu letak negative kx. Okay, perlu letak negative kx. So here, when it's moved, propagate to the right, we write positive. When the wave is propagate to the left, we write positive. Okay, so that's all for 10.1b.